Hi guys, it's me, Dr. Edwards, once again. And so what we're going to do now is I'm actually going to show you a demonstration of the experiment that we talked about in your presentation for the Average Velocity Virtual Lab. And so what I have here is an air track blower. And what this does is it studies motion in a low friction environment, okay? So we're going to use this air track blower, and we're going to use this actual blower, kind of looks like a vacuum cleaner, and it plugs into the back of the air track blower and it blows air all through the air track. Now what happens here are there's some really fine holes all along the sides of the air track, okay? The air blows out of the holes and it causes this to kind of look like it's floating a little bit as it goes down the incline, okay? So it gives it as low a friction as it possibly can. Now, we also have two photo gates. We have one here and one here, and these are devices that are used to measure times, okay? Once we can get the times that this glider is going down this track, we can calculate certain parameters such as the average velocity. We can also look at the actual initial and final times of things as they go through these photo gates. So it has an infrared beam in between them, and as the glider comes through the photo gates, it causes it to break the beam, and it says that it catches it and it goes through and it calculates the time and gives you those values on a computer. So what happens here is we have a Lab Pro Vernier computer interface. It's connected to my computer. This is where I'm going to read the times from. This interface is connected to the photo gates, and the photo gates receives the information from the glider as they're going through. It goes into the interface and then it transmits on the computer so you can get your values, your measurements. And so now what we've done here is we've created this on an incline, okay? So we have something here to help incline this device so it's going at an incline and this thing can go down the air track as such. And so what I'm gonna do for you is I'm gonna run one trial, but on your experiment you have 10. Okay, not 10, but 7 trials. So you'll do all 7 trials. You'll have them in red on your lab reports. All you have to do is perform the calculations for those lab reports. So let's go on ahead and get started. I'm going to go on ahead and show you one trial of this. So it's kind of loud, but I'm going to start it at the 10 centimeter mark each time, from the same position. And so what I'm going to do is I'm going to start my data collector. And I'm going to let it go. So now it took the first measurement. I stopped it before it came back through. So you can see, or you will see on your lab reports, the different times that you have there. Okay? So that's it for this experiment. You do this 7 times. Okay? I'm going to do this 7 times. And I've done all 7 trials for you. And once again, I'll run it down one more time. Hit the data collection button. Let me just go on ahead and set her up. And you just run it through, and it'll collect those times for you. So go on ahead, finish your experiments up. If you have any questions, please contact me at pedwards@ccga.edu. And also you can send me a reminder text and I'll get back to you as soon as possible if you need help. Make sure you handle your uncertainty properly. There is a centimeter rule on the device. So just remember that each one of these little marks here is 0.1 centimeters, okay? If I take half of the smaller scale division, that's 0.05 centimeters. If you convert that to meters, that's 0.0005 meters. Handle your uncertainty properly, okay? And that's it for today. So I will see you guys next week.